If I told you that 85% of the gravity in our universe comes from nothing we can detect, would you believe me? Or that we've been looking for life in all the wrong places? Or perhaps that the very rotation of Earth beneath your feet is secretly choreographing the dance of every hurricane that's ever existed? The universe is under no obligation to make sense to you, but I'm here to help it try. Welcome, cosmic citizens. I'm your personal astrophysicist, and today we're diving into 3 astronomical revelations that will fundamentally transform how you understand your place in the cosmos. You clicked on this video because you saw me with that shocked expression pointing to what looks like impossible phenomena. Well, buckle up, because what I'm about to share isn't science fiction. It's reality that's stranger than anything Hollywood could dream up. In the next 20 minutes, you'll discover, first, how Jupiter is creating an ocean on a frozen moon 485 million miles from the Sun, and why that completely rewrites our understanding of where life might exist in the universe. Second, the mind-bending reality of dark matter, or as I prefer to call it, dark gravity, the invisible force that makes up 85% of all. Gravitational influence in the cosmos, yet remains completely undetectable to our most sophisticated instruments. And third, how the simple rotation of Earth creates a phenomenon so powerful it dictates the behavior of every major storm system on our planet, from tornadoes to hurricanes, and even affects something as seemingly straightforward as kicking a football. If you want to skip ahead, I've included timestamps below for each cosmic revelation. But I highly recommend the full journey, because in space, it's always about the voyage, not just the destination. Now, before we begin our cosmic journey, take a moment to comment below with which of these 3 phenomena you find most fascinating. I personally read your comments, and I'm curious, which of these blows your mind the hardest? Let's begin with what might be the most revolutionary discovery in our search for extraterrestrial life. Have you ever wondered where we might find alien life in our solar system? For decades, scientists focused on what we call the Goldilocks zone, the narrow band around a star where it's not too hot, not too cold, but just right for liquid water to exist on a planet's surface. Earth sits comfortably in this zone. Mars barely clips it. Venus is too close to the Sun. By this traditional definition, we had exactly one potentially habitable world in our solar system, the very planet we're standing on. But the universe rarely confines itself to our limited imagination. Let me introduce you to Europa, one of Jupiter's moons, orbiting the solar system's largest planet 500 million miles from Earth, well outside what we've long considered the habitable zone. Europa is completely frozen on its surface. Temperatures hover around -260 degrees Fahrenheit. By all traditional measures, this should be a dead world, but it's not. If you're enjoying this cosmic journey so far, consider subscribing to join our universe of curious minds. We explore these kinds of mind-bending realities every week. Now look at Europa's surface. Notice these cracks, these ridges, the shifted ice sheets. They bear a striking resemblance to Arctic Ocean ice formations here on Earth. But what could possibly be creating this activity on a frozen moon so far from the Sun? Imagine this rubber ball is Europa. If I squeeze it repeatedly, the ball warms up. That's basic physics. The mechanical energy of compression converts to thermal energy. Now imagine something massive enough to squeeze an entire moon. That's exactly what's happening. Jupiter's enormous gravitational field is literally squeezing and stretching Europa as it orbits. This process, called tidal flexing, pumps enormous energy into the moon. It's like Jupiter is giving Europa a constant gravitational massage, generating heat in its interior. So what happens when you have heat beneath a layer of ice? You get liquid water. Not just a little bit. We're talking about an ocean containing roughly twice the volume of all Earth's oceans combined, hidden beneath that icy crust. Let that sink in. The most promising environment for alien life in our solar system isn't in the Goldilocks zone at all. It's being warmed not by a star, but by the gravitational embrace of a gas giant planet. This completely rewrites our understanding of habitable environments. If liquid water, the essential ingredient for life as we know it, can exist so far from the Sun, how many more potential habitats for life might be scattered throughout our galaxy? The cosmic real estate for biology just expanded exponentially. But here's where it gets even more intriguing. Europa's ocean isn't just liquid, it's in contact with a rocky. On Earth, some of our most fascinating ecosystems exist around deep sea. Hydrothermal vents, where life thrives in complete darkness using chemical energy rather than sunlight. Could similar processes be nurturing life in Europa's hidden ocean right now? NASA's upcoming Europa Clipper mission aims to find out. But before we continue exploring the implications of Europa's hidden ocean, I have to ask, What do you think we might find beneath that ice? Microbial life, complex organisms, or something completely beyond our current understanding? Share your theories in the comments below. And if you think Europa's hidden ocean is mind-blowing, wait until you hear about our second cosmic revelation, something so strange that it challenges our fundamental understanding of what the universe is made of. Imagine you're an astronomer in the 1970s. You're measuring how fast stars orbit around the center of a galaxy. Basic physics tells you that stars on the outskirts should move more slowly than stars near the center, just like planets in our solar system. Mercury zips around the sun in 88 days. Neptune takes 165 years. But when you actually measure these galactic rotation speeds, they're all wrong. Stars at the edges of galaxies are moving way too fast, so fast they should be flung out into intergalactic space. Yet, galaxies aren't flying apart. Something invisible must be holding them together, something that exerts gravity but emits no light or radiation we can detect. We call this mysterious substance dark matter. But that name is actually misleading. Let me break it down for you. What we've actually measured is that 85% of the gravity in the universe has no known origin. We haven't directly detected the matter itself. We've only measured its gravitational effect. A more accurate name would be dark gravity. Think about what this means. 85% of the gravitational influence in our universe comes from something we can't see, touch, or directly measure with any instrument we've yet devised. Only 15% comes from everything we consider normal matter. All the stars, planets, gas clouds, black holes, neutron stars, and everything else we've ever observed. Now you might be thinking, maybe it's just normal matter that's too dim to see, like brown dwarfs or rogue planets. Scientists considered that too. But we've ruled those possibilities out through multiple lines of evidence. Whatever dark matter is, it's fundamentally different from the matter that makes up you and me. Normal matter, like this water, interacts with itself. Water molecules stick together through electromagnetic forces. That's why water forms droplets instead of just dispersing into individual molecules. Normal matter also interacts with other normal matter. When I pour this water into another glass, there's a collision, a splash, an interaction. Dark matter appears to do neither. It doesn't seem to interact with normal matter except through gravity. And most surprisingly, it doesn't even appear to interact much with itself. That's why dark matter remains diffusely spread throughout galaxies rather than collapsing into dense structures like normal matter does. If dark matter interacted with itself the way normal matter does, it would form dark stars, dark planets, maybe even dark life. But it doesn't. This is why dark matter is truly one of the greatest mysteries in modern science. We know it must exist because we can measure its gravitational effects, but its fundamental nature remains elusive. Some of you may be wondering, could our understanding of gravity itself be wrong? That's a valid scientific question, and there are alternative theories like modified Newtonian dynamics, or MOND. But so far, dark matter better explains the full range of observations we have, from galactic rotation curves to the cosmic. Microwave background radiation. If you're still with me after these mind-bending revelations, you're clearly someone who appreciates the cosmic perspective. Consider subscribing to join our community of universe explorers. We venture into these cosmic frontiers every week. Now, before we move on to our third revelation, I'm curious, which do you find more plausible? That 85% of the gravity in our universe comes from an invisible, unknown form of matter, or that our fundamental understanding of gravity itself needs revision? Leave your thoughts in the comments. And speaking of gravity and its effects, our third revelation brings us back home to Earth, where a simple physical principle creates some of the most dramatic phenomena we experience. Have you ever wondered why hurricanes spin counterclockwise in the northern hemisphere but clockwise in the southern hemisphere? Or why long-range artillery operators have to account for the rotation of the Earth when calculating where their shells will land? The answer lies in a phenomenon called the effect, a force that arises simply because we live on a rotating planet. Imagine you're standing at the North Pole and you throw a ball straight toward the equator. From your perspective, you've thrown it in a straight line, but the Earth is rotating beneath the ball's path. While the ball is in flight, the Earth turns. So when the ball lands, it appears to have curved to the right of where you aimed. This isn't some exotic physics, it's simply the consequence of viewing a straight-line motion from a rotating reference frame. But the implications are profound. This effect is why all major storm systems rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. The force initiates a rotation, and then other atmospheric dynamics amplify it into the massive spiral structures we see in hurricanes and cyclones. Let me give you another example that might surprise you. In American football, a field goal kicked from the 50-yard line will be deflected by nearly half an inch due to Earth's rotation. For most kicks, that's not enough to matter, but for very long field goal attempts, it could be the difference between success and failure. Most kickers have no idea they're battling the rotation of the Earth when they line up their shots. The effect impacts phenomena across scales. It shapes global wind patterns, ocean currents, and even affects the precision guidance systems in intercontinental ballistic missiles. Without the effect, our climate would be dramatically different. The great oceanic conveyor belt that distributes heat around our planet would function differently. Weather patterns would be unrecognizable. But here's what I find most fascinating. This powerful force that shapes our weather, our climate, even the rotation of our massive storms, it all emerges simply because we observe motion from the surface of a rotating planet. It's a perfect example of how fundamental physics creates complex and beautiful phenomena. The simple fact of Earth's rotation gives rise to the spiral arms of hurricanes, the paths of ocean currents, and the global circulation patterns that distribute heat and moisture around our world. So the next time you see a satellite image of a hurricane's perfect spiral structure, remember, you're witnessing the effect in action, a consequence of the simple fact that we live on a planet that completes one rotation every 24 hours. From Europa's hidden ocean to the mysterious nature of dark matter to the far-reaching consequences of Earth's rotation, these three revelations show us how the universe operates on principles that often defy our intuitive understanding. The cosmos reveals itself to those who ask the right questions and observe with precision. As I often say, the universe is under no obligation to make sense to you, but with science as our guide, we can decode its most profound mysteries. Which of these three phenomena did you find most mind-blowing? Europa's potential for harboring alien life, the gravitational influence of invisible dark matter, or how Earth's rotation shapes our weather systems? Let me know in the comments below. And if you enjoyed this cosmic journey, I have excellent news. Next week, we'll be exploring 4 misconceptions about alien life that science has debunked, where we'll examine how our search for extraterrestrial intelligence has evolved based on new scientific understanding. Subscribe now so you don't miss it, and hit that notification bell to join us right when we launch into that new cosmic frontier. Until then, keep looking up. Let's delve deeper into why Europa's subsurface ocean is so revolutionary to our understanding of habitable environments. The traditional definition of a habitable zone, sometimes called the Goldilocks zone, was based on a simple premise. Liquid water requires temperatures between 0 and 100 degrees Celsius at Earth's atmospheric pressure. Given that water is essential for all life as we know it, astronomers naturally focused their search for habitable worlds in this narrow temperature band around stars. It seemed logical, straightforward, and based on sound physics. But nature has a way of expanding beyond our limited imagination. Europa teaches us that liquid water can exist in places we never expected, not because of direct stellar heating, but because of other energy sources entirely. Let me explain exactly how Jupiter creates this hidden ocean. Europa orbits Jupiter in a slightly elliptical path. As it moves closer to Jupiter, the giant planet's gravitational pull strengthens. As Europa moves farther away, that pull weakens. This constant change in gravitational force literally stretches and compresses Europa, not by a little but by tens of meters. The entire moon flexes with each orbit. Imagine taking a ball of ice and repeatedly squeezing it. What happens? The friction between ice molecules generates heat. Now scale that up to a planetary body 3,100 kilometers in diameter. The tidal heating generated by this process is enormous, enough to maintain a liquid ocean beneath 15 to 25 kilometers of ice, despite surface temperatures cold enough to freeze carbon dioxide solid. But the implications go far beyond just Europa. This mechanism, tidal heating, could create habitable environments throughout the universe in places we never thought to look. Jupiter has other moons, Ganymede and Callisto, that likely harbor subsurface oceans. Saturn's moon Enceladus definitively has a subsurface ocean. We've actually seen geysers of water vapor erupting from its south pole. Even distant Pluto shows evidence of a possible subsurface ocean. Now extend this thinking to other star systems. Gas giant planets like Jupiter are common throughout our galaxy. Many of them have systems of moons. If tidal heating can create liquid water environments in our solar system, it's doing the same thing in countless other planetary systems. The implications are staggering. The habitable real estate in our galaxy just increased by orders of magnitude. We need to completely rethink where we search for life. Let's look more closely at the evidence for Europa's subsurface ocean. These cracks and ridges you see on the surface, they tell us something profound. The patterns suggest that Europa's ice shell has been fractured and shifted. Some features appear to be blocks of ice that broke apart and rafted into new positions before refreezing. This region, called chaos terrain, strongly resembles ice pack formations in Earth's Arctic Ocean. On Earth, these patterns form when ice flows break apart, move, and refreeze. The similarity suggests a similar process on Europa, which requires liquid water beneath the ice. But there's more. Europa's surface is remarkably young and smooth, with very few impact craters. This tells us the surface is actively being renewed, another sign of ongoing geological activity driven by the liquid ocean below. The evidence doesn't stop there. The Galileo spacecraft that orbited Jupiter in the 1990s detected a magnetic field around Europa that changes as Europa orbits Jupiter. This is exactly what we'd expect if a layer of electrically conductive salt water exists beneath the surface, interacting with Jupiter's powerful magnetic field. These salt signatures are particularly exciting because on Earth, salt in the ocean comes from interaction with rocks. If Europa's ocean contains salts, it suggests the water is in contact with the Moon's rocky mantle, creating potential for the kinds of chemical reactions that could support life. Now, some of you might be wondering, if this ocean exists, what kind of life could potentially survive there? Would it be similar to life on Earth or something completely different? On Earth, we've discovered thriving ecosystems in the most extreme environments, from scalding hydrothermal vents at the bottom of the ocean to the dry valleys of Antarctica to highly acidic mine drainage. Life finds a way, adapting to conditions we once thought were incompatible with biology. Europa's ocean could potentially contain more than twice the water of all Earth's oceans combined. If thermal vents exist on it, and they likely do, given the Moon's geological activity, they could provide both energy and nutrients for life, just as they do in Earth's deep oceans. The life there, if it exists, would likely be microbial, perhaps similar to the chemosynthetic bacteria that form the base of Earth's deep-sea vent ecosystems. But given that Europa's ocean has potentially existed for billions of years, who knows what evolutionary paths might have been taken? This is why NASA's upcoming Europa Clipper mission, scheduled to launch in 2024, is so crucial. This spacecraft will perform multiple close flybys of Europa, using ice-penetrating radar to measure the thickness of the ice shell and sophisticated instruments to analyze the composition of materials on the surface, including any that might have come from the ocean below through cracks or plumes. Some of you watching might live to see the day when we send a probe to actually penetrate Europa's ice shell and sample its ocean directly. Imagine that moment, when we might discover the first life forms that evolved completely independently from Earth's biosphere. The philosophical and scientific implications would be profound. If we find life in Europa's ocean, it would strongly suggest that life is not a rare accident but a common outcome wherever the right conditions exist. And if life has emerged independently in two places just in our solar system, the universe must be teeming with biology. As Carl Sagan once said, extraordinary claims require extraordinary evidence. We haven't found that evidence for life on Europa yet, but the evidence for the liquid water environment that could support life. That's already extraordinary. Let's dive deeper into the mystery of dark matter, or as I prefer to call it, dark gravity. This is perhaps the most profound puzzle in modern astrophysics, and it challenges our most fundamental understanding of what the universe is made of. The story begins in the 1970s with astronomer. She was measuring the rotation speeds of stars in spiral galaxies, expecting to find that stars at the edges orbit more slowly than stars near the center, just like planets in our solar system. In our solar system, Mercury orbits the Sun at about 48 kilometers per second, while Neptune creeps along at just 5 kilometers per second. This makes perfect sense. The gravitational force from the Sun diminishes with distance, so more distant objects orbit more slowly. But when measured galaxies, she found something astonishing. Stars at the edges were moving just as fast as stars near the center. In fact, the rotation curves of galaxies were essentially flat, meaning the orbital speed remained roughly constant regardless of distance from the galactic center. This violated everything we understood about gravity. Based on the visible matter in these galaxies, stars at the edges were moving so fast they should have been flung out into intergalactic space. Yet galaxies are clearly stable structures that have existed for billions of years. The inescapable conclusion: There must be far more mass in these galaxies than we can see, a lot more. In fact, the calculations showed that visible matter, stars, gas, dust, planets accounts for only about 15% of the total gravitational mass. The other 85% is invisible. But the evidence doesn't stop with galaxy rotation curves. When we look at how galaxies move within clusters, we again find they're moving too fast to be held together by the gravity of visible matter alone. When we observe gravitational lensing, how light bends around massive objects, we can map out where the mass is, and again find that most of it is invisible. Perhaps the most dramatic evidence comes from the Bullet Cluster, two galaxy clusters that collided about 150 million years ago. When we map the visible matter using X-rays, we see it concentrated in the center of the collision where gases from both clusters slammed together and slowed down. But when we map the mass using gravitational lensing, we find that most of it sailed right through the collision without slowing down at all, completely separated from the visible matter. This is a smoking gun. Whatever dark matter is, it passed right through both the normal matter and other dark matter without interacting. It's as if two ghost armies marched right through each other on a battlefield. Let me help you understand just how strange this is. Normal matter, the stuff that makes up. You meet planets, stars, interacts in multiple ways. It exerts gravitational force, yes, but also electromagnetic force. It can absorb and emit light. It can collide with other matter. When I tap this glass, my finger doesn't pass through it. The electromagnetic repulsion between the atoms in my finger and the atoms in the glass prevents them from occupying the same space. That's how normal matter behaves. Dark matter appears to interact only through gravity. It doesn't emit, absorb, or reflect light. It doesn't form compact structures like stars or planets. It doesn't clump together the way normal matter does. It just creates gravity, lots of it, while remaining completely invisible to our instruments. This is why it forms a diffuse halo around galaxies rather than concentrating in the center like normal matter does. The dark matter particles, whatever they are, barely interact even with each other. So what could dark matter actually be? Physicists have proposed numerous candidates. The leading contenders are weakly interacting massive particles, or WIMPs, hypothetical particles that interact through gravity and the weak nuclear force, but not electromagnetism. Scientists around the world have built incredibly sensitive detectors, often in deep underground laboratories to shield them from cosmic rays, hoping to catch the rare interaction of a dark matter particle with normal matter. So far, these experiments have yielded no definitive detections. Other possibilities include axions, extremely light hypothetical particles originally proposed to solve a problem in quantum. Or perhaps primordial black holes formed in the very early universe, too small to detect directly but massive enough collectively to explain dark matter's gravitational effects. Some researchers have proposed more exotic explanations, extra dimensions of spacetime where gravity leaks into our three-dimensional universe, or modifications to our understanding of gravity itself. This latter approach, modified Newtonian dynamics, or MOND, suggests that perhaps Newton's and laws of gravity need revision at the galactic scale. Rather than invoking invisible matter, perhaps gravity itself behaves differently than we expect at vast distances or in extremely weak fields. MOND can explain individual galaxy rotation curves quite well. But it struggles with other observations, particularly the Bullet Cluster and the cosmic microwave background radiation, the echo of the Big Bang that contains crucial information about the early universe. The cosmic microwave background radiation shows tiny temperature fluctuations that reveal the density of the early universe. The pattern of these fluctuations matches precisely what we would expect in a universe containing dark matter, but not what we would expect from modified gravity theories. This is why most physicists still favor the dark matter explanation, despite decades of failed attempts to directly detect the particles. The evidence from multiple, independent lines of investigation all points to the same conclusion. There is far more gravitational influence in our universe than visible matter can account for. Think about what this means for our understanding of the cosmos. The stars, planets, gas clouds, black holes, everything we've ever directly observed, constitute only about 5% of the universe's total energy content. Dark matter accounts for about 27%, and the remaining 68% is an even more mysterious component called dark energy, which appears to be accelerating the expansion of the universe. We live in a universe where 95% of its content is invisible to us, and understood only through its gravitational effects. It's as if we've been studying the cosmic ocean by looking only at the foam on top of the waves. This humbling reality reminds us that science is a journey, not a destination. Each discovery opens new questions. Each answer reveals new mysteries. The universe continues to surprise us, challenging our most fundamental assumptions about reality. And that's precisely why science is so exciting. We stand at the frontier of discovery, piecing together clues about a universe that continues to reveal itself as stranger and more wonderful than we could have imagined. The effect may seem less exotic than hidden oceans on distant moons or invisible matter shaping galaxies, but its implications are no less profound. This phenomenon, arising simply from Earth's rotation, shapes our weather, our climate, and even influenced the evolution of life on our planet. Let's start with the basics. Earth completes one rotation every 24 hours. That means that at the equator, the surface is moving at about 1,670 kilometers per hour. But at the poles, the rotational speed is effectively zero. And at mid-latitudes, the speed is somewhere in between. This difference in rotational speed across latitudes creates the effect when an object moves freely across Earth's surface, whether it's a missile, an air mass, or ocean currents, it maintains its initial rotational speed. But as it moves to areas with different rotational speeds, it appears to deflect relative to the ground beneath it. Let me demonstrate with a specific example. Imagine you're standing at the North Pole and you launch a missile straight south toward the equator. From your perspective at the pole, you fired in a straight line. But while that missile is in flight, Earth continues rotating beneath it. The missile maintains its initial rotational speed, effectively zero since it was launched from the pole. But as it travels southward, it encounters ground that's moving eastward at an increasingly rapid pace. The result, from the perspective of someone on the ground, the missile appears to curve to the right of its initial trajectory. It's not actually changing direction, it's traveling in a straight line in absolute space. But relative to the rotating Earth, it follows a curved path. This same principle applies to anything moving freely across Earth's surface. In the northern hemisphere, moving objects appear to deflect to the right. In the southern hemisphere, they deflect to the left. At the equator, there's effectively no effect for north-south movement. Graphic global wind pattern diagram.